Section 11.7 is the last rule that we will be learning, the chain rule. So the chain rule is needed when the function you're looking at is a composition of two or more functions. So we first need to review composite functions or composed functions. And I have a model that I really like of what do you mean when you say a composition of functions? So imagine a factory where circles are coming in and they go through this machine that's called the G machine. And what the G machine does is turn the circles into triangles. And then those triangles go in an F machine and it turns the triangles into squares. Well, if we compose two functions, and the notation we use is an open circle, we say f of g of x, which also can be written f of g of x with this notation. What we're saying is we want one machine that takes the circles directly to squares. So we're basically combining what the F and G machines do into one machine that does the same effect as doing one after the other. So here are some examples of composed functions. If you have the square root of x squared plus 3. We have an inside function, or the function that happens first is the x squared plus 3. So this would be like the g function. And then you have the square root, and that would be like the f function. So you focus on the x first and see what's happening to the x in what order, and work your way outward from the x. So here's another example of a composed function. If I have x squared plus 2x minus 3 to the 4th power. So I have an inside function that's the x squared plus 2x minus 3, that's doing the g function job. And then I have the f function of to the 4th power. So any function that's a function of a function is a composed function, and we'll need the chain rule in order to figure out what its derivative is. So let's do a little bit more review of composed functions. So there are two ways to evaluate a composed function. So the first way I'm going to show you is if I want to know what f of g of 5 is, I can do g of 5 first. Well, we know how to do that. That means plug in 5 everywhere you see an x in the g function, and you're going to get 19. Well, then this notation says now put the 19 that you got into the f function. So you want f of 19. So that's going to be 2 times 19 squared plus 3 times 19. And you're definitely going to need a calculator for these. And I'm getting 779. So that's one way to do it. So now I want to show you the other way, which is going to actually be the preferred way, which is to compose the functions first. So we're first going to find f of g of x, then plug in the 5. Okay, so this notation, f of g of x, the g is what's inside, so that says you take the g function and you put it in the f function everywhere you see an x. Instead, you put the g function. So you'll have 2 times 4x minus 1 quantity squared plus 3 times 4x minus 1. So then we should do some algebra to beautify this, and 4x minus 1 times 4x minus 1 is going to be 16x squared minus 8x plus 1 plus 12x minus 3. So that's going to give me 32x squared minus 16x plus 2 plus 12x minus 3. And then we should combine like terms to get 32x squared minus 4x minus 1. So this is my f of g of x function. Well, now what I was asked to find was f of g of 5. So that means I need to put 5 into this function everywhere I see an x. And sure enough, I get 779 again. So either way works when you're putting a number in. So let's look at b, and because we already composed the function, we can find b by just doing f of g of negative 4. So we can have 32 times negative 4 squared minus 4 times negative 4 minus 1. So that's going to give me 527. And I'm done. So I didn't have to do as much work the next time I evaluated at a different number. And if you want to check, you can say, well, what happens if I do g of negative 4 first? And the g function we're working with is the 4x minus 1. So 4 times x minus 1. So that's negative 17. And then we would have f of negative 17. So that's 2 times negative 17 squared plus 3 times negative 17. And we get 527 that way also. So if you're asked to evaluate at several different numbers, it's going to actually be less work to compose the two functions first and then just plug in the different x values you're being asked about. So let's go back up here and look at the other functions that you're being asked to evaluate and make sure we know how to do those, because they're a little different. The order totally matters. So for this C example, g of f of 5, you would first find f of 5. So f of 5 equals 2 times 5 squared plus 3 times 5, or 65. And then you would find g of 65. So that's going to be 4 times 65 minus 1, or 259. So now let's look at the other way and see what happens if we compose the two functions first, and notice that the order is different than the previous examples. So the other way is to compose first. So we want to find g of f of x. which I like to write better, g of f of x. Because to me then it's obvious that the f of x goes inside the g. So I'm going to take the f of x and put it in the g function. So this is going to be 4 times 2x squared plus 3x minus 1. So that's going to be 8x squared plus 12x minus 1. And now if we do g of f of 5, we're going to have 8 times 5 squared plus 12 times 5 minus 1. And we get the same answer of 259. So then if we're going to do d, all we have to do is take our blue function here, say, let me do g of f of negative 4, and that's going to be 8 times negative 4 squared plus 12 times negative 4 minus 1. And I'm getting 79 for that one. And I'll let you try it the other way of doing f of negative 4 and put that in g. Okay, so we were already practicing doing what the next exercise asks you to do, which is compose two functions. So I have several examples here. So first we're supposed to find f of g of x. So notice that the g is inside the f. So f of g of x equals the square root of 2 times 3x minus 8 plus 5. And you should simplify this because you can. So you'll have 6x minus 16 plus 5 in the square root, which is 6x minus 11 in the square root. So this is f of g of x. And then we're also asked to find g of f of x. So now you see that the f is the inner function. So you're going to take the f and put it into the g function. So that's going to be 3 times the square root of 2x plus 5 minus 8. And that can't be simplified any. Okay, let's look at another example. And this one, we are going to find f of g of x first. So it says put the g function into the f function, and you're done. Don't multiply out the 2 minus x 4 times. There's no reason to, okay? So then let's do it the other way around and say we are also going to find g of f of x, and look and see that f is the inside function. So that says put f inside g. So that's going to be 2 minus 2 over x to the 4th. And that's a good spot to stop. So I'm going to make another video for the rest and pause here.